All right, today we're going deep. I mean, literally inside the world's biggest oil tankers. There's this quiet revolution happening, a story about robots taking on one of the most dangerous jobs out there, and in the process, saving a ton of money, and even more importantly, keeping people safe. So, let me just ask you this. How in the world do you inspect for rust inside a tank the size of a skyscraper that also happens to be a potential bomb? It sounds impossible, right? For decades, the answer was, well, it was messy, dangerous, and just wildly expensive. And that gets us to how things used to be done. It wasn't just a simple checkup, it was a massive, dangerous chore with huge risks, both financially and for the people involved. Okay, let's talk money. I mean, big money. Just to send people inside, you have to pull the entire ship out of service. That's what off-hire time means. And look at that number. We're talking almost 400 grand right there. Then you've got to clean it, you've got to pump in fresh air, and suddenly you're looking at over $500,000. And that's for every single inspection. But honestly, the money isn't even the whole story. The real cost? It's human. Look at this number. 320. That's 320 times human hours spent inside that dangerous tank, per inspection. That's basically weeks of people climbing around on scaffolding inside a giant, dark steel box. You just know there has to be a better way to do this. And you know what? There is. Meet the robotic inspection team. This is the solution, a whole new approach where a team of specialized robots does the entire job without a single person ever having to step foot inside. And it's not just one magic robot, it's a whole toolkit. The best analogy is probably modern medicine, right? You don't just cut someone open anymore. You do an MRI or a CT scan first. It's the same idea here. They use ultrasound from the outside to check the steel thickness. They send in drones, basically flying cameras for a visual inspection. And for the really tricky spots, they've got these little magnetic crawlers that can go anywhere. Now, this right here, this is the absolute game changer. See, to stop these tanks from, exploding, they're filled with this special gas that has no oxygen in it. Great for safety, but totally unbreathable for humans. So the old way involved spending days and a fortune on fuel just to pump all that gas out and pump breathable air in. But the robots, they don't need to breathe. They can just go right in, which completely gets rid of that entire expensive, time-consuming, and dangerous step. So you might be wondering, is this tech actually any good? And the answer is absolutely. We're not talking about some lab experiment. These tools are approved by the top names in the industry, like Lloyd's Register. With accuracy down to a fraction of a millimeter and super sharp 4K video, the data you get is just as good and sometimes even better than what a person could get. Okay, so the data is good. But the million-dollar question is, does this new method actually keep the ship safe? That's what really matters. So let's look at how they actually prove that it works. To figure this out, engineers use something called probability of failure. It's a fancy term, but it's basically a scientific way to calculate the odds of something breaking. They take years of real-world data on corrosion and run the numbers to figure out the risk. It's the same math they use to make sure bridges don't fall down, and they're applying it here. And the results from this analysis? They're kind of mind-blowing. So the industry says an acceptable risk is a 1 in 1,000 chance of failure. That's the benchmark. But with the new robotic method, the risk plummets to 1 in 10,000. Let that sink in. This isn't just as safe as the old way. The math shows it's literally 10 times safer than the accepted standard. And it's not some rogue idea. All the big players, the ones who write the rules for global shipping, they're all on board. They've all published official guidance that says, yep, these remote inspection techniques are good to go. So we've established it's safer and it's officially approved. Now let's get to the part that makes everyone's ears perk up, the payoff. We're talking huge savings in both dollars and, more importantly, human risk. Okay, this slide really puts it all into perspective. Just look at the difference. The old school manned entry method on the left, you're talking over $500,000. The new robotic way on the right, $15,000, maybe $20,000. I mean, the difference is just staggering. It's not even in the same ballpark. So what does that work out to? An average savings of more than $500,000. And remember, these inspections happen every couple of years. This isn't a one-time thing. It's a saving that keeps on saving for every single ship that adopts this method. And if you zoom out and look at the whole life of a ship, the numbers get even crazier. Over a typical 15-year lifespan, we're talking about a net savings of $3 million. That's per vessel, just from this one change. And maybe the most important line in the whole study is this one right here. It says that operators can adopt this new way of doing things immediately. This isn't some pie-in-the-sky idea for the future. It's ready to go right now. Which brings us to our final point, really. The future is now. This isn't about what might be possible someday. We're talking about a smarter, safer, and way cheaper solution that's on the table today. So let's just boil this all down. What are the big takeaways? First, it keeps a ship just as safe, if not safer. Second, it gets people out of a dangerous job. No more 320 hours in a confined space. Third, it saves an absolutely massive amount of money. And maybe the most important part, this isn't a someday thing. It uses rules that are already on the books, and it's ready to go right now. And that really leaves us with one big question, doesn't it? I mean, inspecting oil tankers is an incredibly dangerous job, but it's just one of many. When you see how well robots can take over here, you can't help but wonder, what's next? What other dangerous jobs are about to get their own robotic revolution?